So yeah, this presentation is titled Turning Up the Heat, Min-P Sampling for Creative and Coherent LLM Outputs. Um, and actually, just give me a second. Just getting my speaker notes all prepared. Hold on. There we go. Um, the subtitle for this, by the way, is "Making All LLMs Better for Free," and I promise you that this is actually true. At least all LLMs that you can locally download or run. So unfortunately, the asterisk here is that at the moment, this technique is not available for ChatGPT, Claude, or Gemini, which is very annoying. But otherwise, it's available for any other model: Llama, Mistral, DeepSeek, Qwen. This works. And it could work with Gemini or ChatGPT. That's a limitation that on purpose they don't support this method, which you'll understand why as we go through the presentation. Um, before I even go into what is a sampling algorithm and what is min-p sampling, I have to go through LLM 101 and discuss like how a model chooses its next word to set the stage. So uh, Formally, when an LLM generates text, it's essentially playing a word by word prediction game. For the phrase, the cat sat on which is a phrase that we show in the slide, it creates a probability distribution like you see here. And here we just show, mat, rug, floor, and moon. But this probability distribution is over every possible word or token, or more formally, in the model's vocabulary. And the vocabulary of these language models, well, the very first ChatGPT had a 50,000 word or token vocabulary, and now they're in the several hundred thousands. But the vast majority of these probabilities are so infinitesimally small they can be ignored. Things like 0.01% or less, and it's usually for most times the model will have maybe 1 to 100 things that it will assign a probability above, say, 0.1% to. Um, Matt right here is the most likely continuation, but rug and floor are also very plausible. And so sampling is the strategy we use to pick a word from the list. And of course, there's this very naive approach, which doesn't have good diversity, but is used, sometimes even used in serious like reasoning tasks, which we would call greedy sampling, which is just choosing the top option. So in this case, just always choose whatever the highest probability token, Matt in this case. But this creates dull outputs, right? And always, the same outputs where you want to be able to like, press the same like, regenerate button and have it give you different outputs. And that's not possible if you're always sampling the top token. It's always the same. So what we can try instead is like a weighted random sampling or even a full random sampling from this whole list. But if you did full randomness instead of like a probabilistic weighted sampling, then you would just get complete nonsense and gibberish, right? So the magic where we get creativity and coherence is somewhere in the middle. And so that's what sampling algorithms modulate. So the standard toolkit for how we do this today, and for those of you who are familiar with using any of the major libraries, like implementing apps, building apps with them, using their API, accessing them through Python or some other programming interface, you might be familiar with some of these techniques. In particular, you might have heard of phrases like temperature, top K, and top P, but pretty much unless you're in that world of like building Gen AI apps, you've probably never heard of these. But they are at the heart of how models generate at every time step the next word, the next token. So I already talked about greedy decoding, and again, I mentioned that this is used in the real world still for like reasoning tasks, but is considered kind of the baseline and the most uninteresting technique. And then we have temperature, which I've also talked about, or sorry, we'll talk about now, which allows you to take this previous probability list and start, if we increase the temperature, we scale down the high probabilities like mat and rug, relatively speaking, while we scale up floor and moon in their probabilities. So if you take temperature to like an infinite temperature would make all the words have an equal probability, equally unlikely. And so the idea then is um, weird words become more likely at high temperatures. And so we quickly start getting nonsense with high temperatures. In fact, without any kind of sampling algorithm chosen, a temperature much above 1.2 on most models of today causes them to turn, into gibberish, basically, or degenerate outputs is a more formal term. So in order to enable high temperature sampling, temperatures of 2, 3, 5, 10, 100, which is what allows you to sample from the deep, more, unlikely parts of your model's distribution, this is the key to diversity, and hence why we titled our paper "Turning Up the Heat." Min-P sampling for creative and coherent LLM outputs. We turn up the temperature and we enable this. So that gets us to, the question of, well, how are ChatGPT and Claude and all of them doing sampling today? And they're using the most ridiculously simple sampling algorithms that pretty much a 5-year-old could have developed. And they actually choose these on purpose because advancements in sampling algorithms enable high temperature sampling, and that's explicitly not something that the big three closed source model providers want to provide, because you can break their alignment and safety mechanisms when your model's allowed to be too creative. So that's why they keep on purpose like these primitive sampling algorithms. But top K is simple. It just says, okay, at every time step, if top K is top 5, K is 5, then we only allow you to sample from the 5 most likely continuations with their probability. So in this case, it would be mat, rug, floor, moon, and then whatever the next one is, which would be 5 words out of a vocabulary of, potentially hundreds or hundreds of thousands of words. And this is good because in a sense, because it means that even if we start setting temperature high, in a lot of cases, we maintain creativity when K is very low, but this is not like adaptive because the model tells you through this probability distribution when it's very sure of itself and then when it's unsure of itself. So there are going to be times where the top most likely token is 99% likely, and even the second most likely token is like 1%. And in that case, the model is trying to tell you, no, I really just want to sample from the most likely word or token. But here you're ignoring it and allowing things that shouldn't be in there into the distribution. So top K has problems, right? It's either too restrictive or too permissive based on the choice of K. And then we have what is called nucleus sampling or top P sampling. You can think of this as like a probability budget. And so the idea would be if your top P is 0.9, then you have a probability budget of 90% of the total probability distribution. So if the top 5 words have probability that sums cumulatively to 90%, of all of it is covered here. In this case, 40 plus 30 plus 15, that's 70, it's 85, right? So we just the top 3 words sum to 85, right? The idea is your budget is okay, you can allow all words until you've hit this, in this case, 90% budget. And this is currently the industry standard, or actually the industry standard is to combine top K and top P. And Gemini actually hides the fact that they have a hidden top K of 6 or top 64 sampling that you can't disable, which is a fun little quirk. But together, even top P and even running together have this fatal flaw like high temperatures, which is that at a high temperature, when the high probability words are lowered and dampened and the low probability words are increased, this creates a flat distribution. And then the budget from top P starts including a huge number of these like low quality tokens. And so now we have this problem of breaking coherence or the opposite of being too restrictive and collapsing. But like if you're too restrictive with top K or top P, you've become almost greedy and thus undiverse and uninteresting. So this is these two slides. I'm sorry if I had to like run through them fast and if some of this might be confusing. I'll say that sampling is something that is still rapidly advancing and it's mostly an empirical world. And I would encourage you all to, if parts of this are confusing now, to go through and Google and research or even ask ChatGPT what words like greedy decoding, temperature, top K, and top P mean until you get them, because they're really at the heart of what ChatGPT and what these models are doing at every moment. So I've now sat or set the stage for the problem, and so now I'm going to go to a detour for a moment to an event that happened at a AI conference where we pitched this MinP sampling idea, and we actually pitched it to a man whose name I don't want to use because he's so famous. But I will give you a hint that the combination of the hair on this figure and the fact that they're, described the way they are, you can quickly figure they are. This is kind of an if you know, you know situation. And I want to point out that this researcher saw this presentation, right? This whole thing, and gave the first question. So I clearly did what I was trying to do, which was call them out for shooting down a good idea. Because at the conference I was presenting this, the paper that we're describing had been accepted as like a top 1% paper. And this was after this famous AI researcher told us that this idea wasn't good. So this is me kind of recanting that story, me cornering him in, I think it was like a workshop where he had some sandwiches. And so I tell him, hey, we have this paper at, this conference that I was talking at with excellent scores about a new sampling algorithm, and the researcher is not very pleased because he probably hears these elevator pitches 24/7, but he accepts it. And then I tell him, hey, we have this cool technique. It's called min-p sampling. It beats top p sampling, which I just described earlier. We do this thing called dynamically truncation, and then he's like, wait, another sampling method. And then he responds, wait a moment, you don't need sampling at all. Temperature is all you need. Why do you need this? And then I'm telling him, wait a moment, how are you living under a rock? Everybody, everywhere, ChatGPT, Claude, they're all using these sampling algorithms. And finally, he looks at me and tells me your elevator pitch sucks because we didn't have very much time. You had to go to the next thing. And this broke my heart and also left a chip on my shoulder that I only properly healed by getting this paper, accepted and having him see this comic and actually ask very nice questions to kind of indicate that he understood now. So I want to point out that academia and the mainstream AI industry has inertia against the idea that we can advance the quality of samplers or of language models at the sampler level. But academics such as this highly ranked scientist here might have ignored innovations that were being empirically discovered. There was a different crowd that was sort of looking into that world, and so the academic specific and industry spends billions scaling model in size and compute, right? But their final step was treated as an afterthought, right? And so I guess our argument with our technique and we think that we've been validated by the fact that the mainstream open source language model community has integrated min-p sampling throughout their ecosystem, Hugging Face transformers. Our argument is that we are living in the stone age of samplers, right? And that by improving it, we get the single best price to performance ratio for enhancing LLM capabilities right now for your customers, right? And I think start meeting questions. Yes, okay, I'm just starting these questions. Whoops, sorry, just trying to get this out of my way. But and then go back slides. So our thesis is the potential gains from smarter sampling are enormous, and that most of academia, at least, had missed the boat. And even, folks like consultants here at ThoughtWorks are simply unaware of these techniques because academics haven't done their job of signaling and signposting, right? So where the innovation ends up happening is enthusiasts, right? So since academia isn't leading, we look to open source LLM front end communities. So we have these really large projects such as, and the names are ridiculous, but it's Uba Booga Text Generation Web UI, which is kind of like a front end designed to be kind of like a power user tool, like a Photoshop for Chat GPT or for language models, except since there isn't really a proper paid for product yet, it's being built in open source land. And so these classes of projects have integrated dozens of these sampling algorithms and techniques that start manipulating your model's probabilities in some way to meaningfully change them or steer them beyond the traditional techniques made available through top K, top P, and temperature. Um, and by the way, often the reason why this particular community and crowd is doing this innovation first is because this is the crowd who's focusing and using AI companions and all of what that entails, running things locally. And so there's certain, I guess, and similar to Silly Tavern. Silly Tavern is also pretty honest about being ultimately for like, AI companion type things as a use case. And so while that kind of use case might be a little more seedy than others, we look to the major model inference engines like Hugging Face themselves, where you've probably, if you've run a local model on your machine or even for a client, you've probably used Hugging Face, and then VLLM. Sorry. VLLM and SGLang, which if you've done, deployments of fast models, like if you've got a client who wanted to had like 10,000 users and needed to, host Llama 3 for those users at scale, you've heard of VLLM and SGLang. And all of these projects also are supporting fancy more innovative sampling algorithms, including MinP sampling. And in fact, us getting merged into these projects is really a great honor, I would say, given that large swaths of people running models today are running it using a sampling algorithm that has my name on it in some way. Um, so these communities discovered crucial details that academics missed, like the fact that the order of applying things like temperature and these truncation samplers matters. So I haven't even discussed this intricacy, and it's maybe too much complexity now to go deep in it, but this is something that the vast majority of academia ignored in such a way where all reproducibility is gone now. Because, for example, Hugging Face and VLLM, two of the most important inference engines, which are powering experiments in papers and sometimes aren't even being reported which one is being used, have an opposite order in: do we apply temperature and then run a sampler like top K or top P, or do we run the sampler first and then apply temperature? And that has massive impacts, like so extreme impacts on your outputs that I can't overstate it enough. And then worse yet, the same dynamic exists with like stable diffusion and generative images. So we see in the closed source ecosystem, the open AIs, your Geminis, they don't give any kind of control to fancier, what are called stochastic differential equation solvers, the equivalent to samplers for image generation. But open source users who are often doing it for seedy underbelly of AI stuff have innovated in ways that have gone far beyond traditional academia, right? So this dynamic happens in multiple areas in AI systems. Um, so the elephant in the room is that the actual process of generating text, the sampling is that elephant, right? We tweak hyperparameters like temperature, top P or top K, but fundamentally we hit a wall. If you want diverse creative output, you crank up the temperature, but push it too high. And here, too high are numbers that I think are hilariously low, like 1.2 2, 1.5. And even with top P and top K, and even if you've chosen a setting that's right for one prompt, eventually you find a prompt where the model starts spitting out repetitive loops, nonsensical phrases, just loses the plot entirely. So we get creativity or coherence, rarely both. And by the way, creativity is just hallucination when we want it. Hallucination is creativity when we don't. So we're even okay for most use cases that are not direct factual reporting of facts being a little bit fungible, right? I mean, good creativity in many cases, this is a similar analogy to the idea of like genius and madness being a fine line, or even the idea of artists being the traditional group of people who want to, take mind-altering substances, for example. Um, so we can analyze and understand like why existing methods struggle at higher temperatures. And this is where we start going into the science and an explanation for what is this min-p technique that I've alluded to earlier on, right? Um, or let's, increasing temperature acts like smoothing the probability distribution. So everything becomes much more equally likely at high temperatures. Now, top P sampling keeps tokens until their cumulative probability hits a threshold. We said 90% or zero point 0.9 before. This nicely captures the nucleus of likely tokens when the distribution is sharp, but when it's flat, it includes a huge number of tokens which are actually nonsensical in context. And top K, again, isn't much better because a fixed K doesn't know if the model is uncertain or is confident or uncertain. It just blindly chops off the tail, potentially removing good options or keeping bad ones. And here, I want you to look at the fact that this black dividing line here for top P and top K, these are vertical lines. In the sense of where we do cutoffs in a probability distribution, our technique makes a horizontal cut instead of a vertical cut. And we'll explain what this means. But even geometrically, it should be more intuitive why a horizontal cut is more useful here. Um, so this is where we get to min-p sampling and our work. The core idea is refreshingly simple. Stop using a fixed cutoff. Let's make the truncation threshold dynamic and dependent on how confident the model is at that very moment. How do we measure confidence then? We use the probability of the single most likely token P max. Now, recall earlier in my slides, I forget what that token was, but the top token had a 40% chance. The top token is P max, right? Just remember this. This is the most likely token. And our argument is your model, if we use P max to tell us if the model is confident, right? So if Pmax is high, we should be more conservative. That's a model saying we want to filter out the majority of the tail of low probability stuff because we should just say the top one or maybe the second most likely token. But if the Pmax is really low, like if the top likelihood token is just like 10%, for example, then the model is like, well, I don't know. There's a bunch of stuff that's quite likely. And that means that the model is telling us it's okay to be diverse in this time step. We can afford to explore more options relative to our current uncertainty. And so min-p will still cut off, your unlikely 100,000 tokens that have 0.0001% probability, but preserve the token that has zero point 0.1 or 0.01%, which is still something that in this case, your P max of 0.12 or 1.3 is saying, hey, that's still possibly viable to say. So this technique is really simple. It's literally in our case, an empirical min-p value of 0.1 seems to be good. So this is a multiplier on top of your top token's likelihood. So in the top example, if we call this 0.48, or let's just round it up to 0.5 as the most likely token, zero point 0.5 times 0.1 is 0.05. And so 0.05 is the threshold where all tokens whose probability is 0.05 or less are now cut off. So that is how it's calculated. And so this is a more like formal description of the algorithm, which I could probably skip, given that you guys aren't a bunch of like academics. But I'll just humor you for those who aren't scared off by the math. Um, at each step, find the probability of the top token P max. We second introduce one new hyperparameter P base. This is the minimum relative probability we're willing to consider 0 0.1 or 10%. What I said was the empirical min P of 0 0.1 we talked about. We multiply P base by P max to create P scaled, which is the say 0 0.1 times 0 0.5. So now 0.05 is P scaled. Then we build our sampling pool by only keeping these tokens whose individual probability is greater than or equal to this dynamic p-scaled threshold. Finally, we renormalize the probabilities of the kept tokens and sample as usual. That's it. By the way, as I alluded to, this happens in an ordering, so you can also run min-p before or after other sampling algorithms, which are potentially further filtering the distribution, and run the temperature scaling before or after. So this is one of potentially many operations that operate on your log probabilities or probabilities. But oftentimes we find that running it by itself is perfectly fine and you don't need to combine it with anything else. Um, but let's discuss why this works. Um, it's such a simple change that makes models work when things get hot. And the key is that min-p filters based on the relative likelihood. A token needs to be at least 10% as likely as the best option to ever be considered. Even if the top token's probability drops significantly, our threshold p scaled drops with it. So we still prune away the garbage tokens that are unlikely relative to the now less certain top choice. And this prevents the incoherence plague we see with top P at high temperature. It naturally balances exploration and exploitation based on context. Oh, and by the way, this is all really, really cheap to compute. The compute cost of calculating P base, P max is effectively free compared to the compute costs of running your GPU and everything. This is like one operation when you've already done like hundreds of millions of operations. So it's basically free, right? And this is also easily integrated into pipelines everywhere, which is why the community has adopted it in such widespread amounts today. So it really is just a win-win. And so we did some experiments in our paper, and I'm going to go through these quickly because, again, you guys are mostly not scientists. But we showed that for, Mistral 7B, Llama 3 family from 1B to 70 billion, and Mistral large on graduate level question answers and grade school math questions that when you look at all sorts of different sampling algorithms at all sorts of different temperatures, we start seeing min-p dominating them. And it becomes like the domination is so extreme that in many cases the models are generating gibberish to the point where it can't even score the outputs at high temperatures with traditional sampling algorithms. But our technique at everything except the lowest, temperatures is superior. So we also show that for creative writing, humans as well as LLM judges prefer outputs that are generated using min-p sampling. Um, and yeah, and then this is the human evals. So uh, I'm gonna finish up by talking about like community impact and where you can use this, and then I will give a demo of how easy it is to swap out top P and top K sampling with min P sampling in your own code projects. So I just want to reiterate, of course, that we had rapid iteration, right, in adoption by major open source frameworks. And the reason that happened, specifically Hugging Face, VLLM, and Olama, wasn't because of this paper. Actually, this technique was invented in 2023 and was around and integrated before 2 years before the paper. It was because practitioners and developers in the open source community found it worked. It solved a real pain point, which is uncreative outputs. And that was especially impactful for the role-playing community. And then we even saw providers like Unsloth and DeepSeek themselves explicitly recommend using min-p as the sampler for DeepSeek R1 to, in their words, prevent repetition of rare or counteract very rare token predictions. So we know this works beyond and knew it worked even without the science that we had to do for it. So I'll give you a final call to action before I go into the actual demo, which is that sampling is awesome. Please learn about it. And furthermore, that there are advances beyond MinP that are coming out, pretty much every AI research conference. There's one that we're really excited about called Top N Sigma, which rather than using the top token of the distribution, they use the whole distribution to inform the filter truncation. And we have a upcoming technique developed here at ThoughtWorks, which we call P-less decoding. I also like the name Moment P. And much as I'd love to share it here, I've been informed to not share it yet, even amongst ThoughtWorks internally, while we still test and iterate and experiment. But we have much more coming up with our name on it that we can say, developed here, and that you can, use as a real bargaining chip, I would say, for getting business for consultants by saying, look, nobody else except ThoughtWorks, really has like a research team that's obsessed with samplers or understands their value, and beyond that, understands how to integrate the state-of-the-art ones into customer projects. So without further ado, I'm going to show you two examples. One of them is how simple it is to run Hugging Face transformers on your laptop. And so here we go into Cursor. I'm going to clear outputs real quick. And I'm going to also just say that I'm running on my an M series MacBook Pro with an M4 chip, which is a very powerful chip. I don't know if everybody here on this call has similar hardware, but it's nice in the context of having lots of GPU RAM, so I can run pretty big language models, relatively speaking, on this laptop locally. And so the hardware, like what you have available that you can run, will differ. But for now, I've chosen a very small model here, a 1 billion parameter Llama 3.2. This is originally from Meta, but this company Unsloth has done some bug fixes for it. So I have some code here. You can ignore this anti-slot stuff. I have some code here for running this model from Hugging Face. Because I'm on Apple, I need to tell it to use Apple Metal. Basically, if you were on an NVIDIA, you would put CUDA here, but MPS for now. And then I can tell it load the auto casual LLM. If you've ran Hugging Face models, this is a traditional kind of recipe, right? So I'll run this and I will load the model. It'll take maybe a minute or two. Yep, and it tells me model loaded. So now it's ready to run. So let's do a really basic prompt. What uh, what do a bunch of ThoughtWorks employees do all day, right? Funny question to ask. And then we can give it all these settings, right? So as I mentioned before, there's all these settings and complexity that's normally hidden from users in ChatGPT, but in an API, we care about that. So we're going to tell it, okay, generate 100 tokens for me. And then we're going to use a very high temperature. I claim you can't even set the temperature above 2 in ChatGPT, Claude, or Gemini. But I'm going to show you temperature of, hell, let's go up. Let's go 5 with the min P of 5 and see if we get coherent output. And so this is standard stuff for detokenizing. But I don't want to go through that, but basically this is just getting the text back from the model after we've loaded and ran it. And so this, you can ignore this warning at the top about attention mask, but then the answer is according to interviews, the tasks involved may include the employees of ThoughtWorks work in distributed teams of developers and architects who design and deploy software. A significant portion of the team includes engineers who work with multiple teams of engineers to solve real world problems. And then now if I rerun this, I should get something totally different. And then, yeah, and now it's so different. It said ThinkWork instead of ThoughtWorks, which is really a sign that the temperature is probably too high. So if I set this back down to 3, it should use our proper name again. Yeah, there we go. And then, according to various sources, Glassdoor and Indeed, software engineer at ThoughtWorks on the following tasks: writing high quality code for a variety of projects, collaborating with engineers, and etc. Right? So, if you think about this in the context of maybe you have a customer that wants to do synthetic data generation with highly diverse outputs, you don't have a good path forward for them without good sampling algorithms. Like all really synthetic data that we know of that we can create will involve either high temperature and then a sampler to clamp down on that temperature, a good one like ours, or some tricks, such as, for example, if you wanted to generate a huge amount of synthetic personas, you can find a real like name, like 100,000 real first names and last names, and have like a prompt that's constantly shifting with a different name and stuff. So like a templatized approach, but that's not scalable the way just being like, hey, I want temperature of 99 or something is, right? So this is kind of like a baseline. I want to point out that for real customer deployments who have large, like who need economical inference, Hugging Face's transformers, the way I'm doing this, is not the fast option. The fast option is, as I mentioned before, VLLM or SGLang, or even I think Hugging Face has their own Transformers inference engine. They all have a very simple, similar interface, right? They will have their own code that you'll have to run, or in the case of VLLM, you'll be running like a command like VLLM serve. In fact, Hugging Face will tell you these commands. I want to point this out. Hugging Face Llama 3. Uh, Hugging Face has a drop down here, so it will show you here's how to use the model in transformers and gives you the code, right? In this case, I used this bit of code from here to load it directly. Or if you wanted to run it in VLLM, they have it here. And so first they'll tell you install VLLM, then serve it, and this will create a server, just like an OpenAI. If you know what OpenAI API compliant server is, the kind of server that you're used to if you use that API, it creates an equivalent one that follows that spec, but on your local machine or pointed to whatever IP address you want. Served from there. And it supports additional arguments that ChatGPT doesn't, such as MinP, right? So then, this is where you give it like a curl payload, and then you can actually specify in addition to this like MinP with whatever value, and it will work. So the point here being that we have paths to quickly just say, hey, customer, are you just running model.generate with nothing specified here? Like, do you just see something like this? If so, there's a hidden default of top key. Usually, I think it defaults to 0.1, and min p usually defaults to turned off. So you can go in there and charge them potentially, consulting fees basically to start playing with these settings. And or even automating the process of sweeping all the possible settings and deciding which combination of them gives the best performance on a particular data set or a particular task. So hopefully you start seeing some initial kind of idea of value add, but I'll finalize the presentation here and then go to Q&A for the last 15 minutes by showing you Uba Booga text generation web UI to show you not just to kind of cement this idea that this is integrated and implemented everywhere, but also to show you very directly the difference in model quality. So here I have open Uba Booga. I showed a screenshot of this, but I've got it running right now. I'm actually going to load a Gemma 3 27 billion parameter model, a very large model. It's been quantized down, so it had a lot of tricks to kind of reduce the size. And this obliterated name in the model means that it's had all refusals. So this is a fully uncensored model. Technically dangerous. Like this could like write code that can hack things, but they're very interesting to study these models from a research perspective for like mechanistic interpretability and AI safety, which is one of our things we work on here at ThoughtWorks. And luckily, models of this size are not dangerous unless you're, like they're not dangerous when ran on their own as agents, right? They're not powerful enough for that. But we've run. So we have it loaded, and the first thing I should show you is what happens when we have no samplers whatsoever. And if we have temperature of 0.1, I guess, it should give me basically the same output. So if I tell it remove last reply, tell me a story, right? Now it's responding with, all right, settle. This one's a little strange. Old man Tibber, right? And then if we regenerate this, it's just giving me the same thing, right? Old man Tibber again, right? So this is uncreative. Now we can do something like a temperature of just 1.2 by itself, and we might get something much more creative. Again, we're not running any other samplers. But I claim that this is still, first of all, we're finding that it's still not that creative. Like it's now a little more interesting, but it's still, fixating on old man Tibber. And this is an example of post-training. Like if you're wondering about LLM slop and where that comes from, like terms like delve, certainly it's not X, it's Y that you see all the time from LLM continuations. It's because during the instruction post-training, they over fixate on very limited training data, and clearly somebody who wrote one of those examples wrote that exact name. And so but we can get around this and we can say, okay, what about at a temperature of like 10? And then that if we do a temperature this high, it's just, I claim gibberish, right? um, Look, complete and utter gibberish. You've probably never seen a chat GPT model generate this, right? So now we need to clamp down on this and put a filter. And here, I'll just show you that top P doesn't do very well. So if I do zero point 0.9 here, which is, and I regenerate, gibberish again. Look at that top P failing, right? The so-called, the one that chat GPT uses. Even if I do like zero point 0.5 on top P, it will probably be a little better and then gibberish. Oh, gibberish again. Okay, cool. Um, then what's it 1.0 then? So if we did top K of like 10 for example here, we'll actually get some somewhat interesting outputs, but I think we'll still get gibberish eventually, right? And maybe um it'll take some time, right? Whiham when in old tube, right? But like it's looking a little bit okay, but if you start like squinting and reading this, it starts getting really weird, right? So top K is having its problems too. But then we can say min p, and here we'll probably want a somewhat restrictive min p of like 0.5. And then now we're getting a very interesting thing. Old man Tibber's gone, right? But whatever it is, it's coherent for the most part about button obsessed civilization, lost buttons, right? A button bot. Like this is ridiculous, but this is crazy. It's like creative, right? What is the worth of a button if not for attach? Like I've never seen ChatGPT tell me a story this good, right? And then let's regenerate. Now we get, okay, a robot named Bolt who wants to be a dandelion, right? So hopefully you're starting to get that for creative writing, which is probably important even in the context of if you're trying to say, okay, I want 100 different variations of an answer on how do I solve a problem, and then pick from these what the best one is. You want diversity in this 100 variations. So from the perspective of reasoning, we show that improving diversity in outputs also improves reasoning, at least on what's called chain of thought outputs. So I've gone really fast. I've talked a lot about topics and I'm sure I've gone over the head of many of the people in here, but I hope I've done a little to convince the folks in here that sampling matters. It's the elephant in the room, and if you learn about it and learn how to audit customers in their settings and choices, you can give them massively better outputs for, in many cases, far cheaper with far more controllable models and give them a better experience. So with that, I'll go to Q&A. I see there's a chat here. I'm going to open that up and start reading it now. Um, okay, so yes, okay. So the first question is, usually we use the four of these methods. Is that so? So we don't need to choose one or the other, but a combination of the four. So first of all, there is still, with the exception of the papers that I and a few, maybe 5 to 10 other research teams on Earth are writing, there's no science on this, right? Like it's very empirical, where figuring out the best settings is generally what I've just done right here, which is like tuning it a little bit and regenerating and being like, does that look good or not? Like vibes based. So empirically, it has been found that a top P and a top K that are both like individually somewhat non-restrictive, like kind of allow a large amount. So like a top K of 64 and a top P of like 90%, which is generally permissive individually, but when you combine both of them, you tend to get pretty good outputs. But what especially happens is that long model outputs, like when the model is generating 64,000 plus tokens at once, which is often something you don't even see in Chat GPT, they tend to have very limited output response lengths. But we find that even the combination of top P, top K starts failing for very long response lengths, but min P doesn't. And we didn't talk about that much in the paper or the presentation, but yes, that's a big benefit. So then Kathy asks about benefits of reduced gibberish, reduced token costs. Yeah, so it's reduced gibberish at high temps. The downstream reduced token costs would come from, let's say you're doing a task where it's this whole thing of like AI agents where they need to generate they need to try many things and they need diversity in when they're trying things, like if they're hitting their head against the wall, like trying at some combination of actions that are continuously failing, using minp with high temperature will get it out of that local minimum and tro of like wasting tokens. So for agents we claim that eventually we reduce token costs, but samplers themselves do not interact with token costs in like a non-agentic. Like the argument would be that better reasoning means fewer tokens for that answer, but that's over thousands of generations. I can't say for any one response. So it's a general yes, but also no to the token cost thing. Um, then the question is, are there scenarios where more traditional sampling methods are still preferred? First of all, greedy sampling on benchmarks tends to show either greedy sampling or almost greedy sampling due to, there's a paper that shows that greedy sampling is actually harmful due to precision, like numerical precision things, which is again also very scientific and goes even over my head. But greedy or similar to greedy, highly restrictive, almost greedy sampling is sometimes preferred when you're doing like non-chain of thought, like if you just want to one shot an answer and see what gets you the most likelihood of being correct. But when you want creativity and when factuality is either not the primary objective or doesn't matter at all, then traditional methods are not preferred. So traditional right now is still in the for factuality. So next question, then the question is, in the demo, what does the min p value do? It's yes. So you unfortunately do not see at every time step the effect of the technique. So there is actually a sampling visualizer. Uh, hold on, just let me see if I can find it real quick. Yes, yes, this. Okay. There is an online demo which tries to give a visual explanation of this and also has min-p here. So I'm going to close this. So let's say this is for this time step. Avocados are rich in monosaturated fats, which are necessary to brain function, cognitive development, and the blank, right? So this is that at this time step, what token do we generate? And so right now, whatever this model is, I assume it's a llama model, has these probabilities for the continuation: absorption of 24.9, health of 23, and etc. And we have nothing. This is just raw. It can generate even, it's not showing the remaining tokens, but it could generate this token theoretically with that percentage probability. So let's show what happens as we increase temperature, right? So we enable it, and then I increase it at temperature 5. The distribution is looking a lot more flat instead of peaky, right? Where absorption is down to 4%, and this one that was previously 0.01 is like 1.1%. So that, hopefully you can see this visual here. Top K does what it describes, and you see how what it's creating is a vertical line, cutoff. So top K of 2, this is it, and it's renormalizing probabilities, right? So it's showing you the probabilities uh after it's assuming that you run temperature at the end, but again you can actually reverse the order even though this demo doesn't show it. And then we can show again what this looks like. What's for top P. And it's coming bottom up like this, but it's like this particular bottom doesn't change at every time step, right? But then min P, and it's also showing it come up as a bottom like this again, right, for its cutoff. But if you could see it go on to the next continuation here, which this demo also doesn't show, you would see that this min P cutoff would adjust itself at every time step. So it's not like a uniform the way this top P is, where this top P red cutoff is always the same no matter how the distribution is changed. But the min P one will change itself for different tokens, is my claim. And here it's not changing because min P is running before temperature, not after. But if we'd reversed the order, you'd actually see the min P cutoff adjust as I moved temperature. But it's just and unfortunately, when I talk about how AI has a lot of low-hanging fruit, going and writing a demo of visualizing of the sampler outputs at every time step is a huge value add right now that I don't know of being done. I think that somewhere in here there's a way to like visualize these logits, I think. So I can, what is it? Tokens or something. If I wrote hello, this is food. I don't know if that will. Then if I generate, I think it might try to. Okay, there's some tools to try to allow you to visualize these, like right here. So like here's the output, and but they're not very good as you can see. Like we need much better for like visualization of what's going on with this. So okay. Then great demo, great work. Is there a GitHub repo? So we do have the GitHub repo for the paper itself, which is where you will find the initial code from 2023 and the stuff for running experiments. But what you're probably asking, which is how do I run MinP for my customers? It's already in Hugging Face. So to answer you, the GitHub repo is just Hugging Face transformers or VLLM or SGLang. And then if you go into their model, like their model generate like settings in there, like the parameters, basically like what you saw in here, like the AP, the documentation for model.generate in Hugging Face, then it will have a little blurb in there about MinP, right? And so that's where so you don't have to do much work is what's nice. That's why I'm like pushing this so hard is like you probably already have the GitHub repo on your computer is my claim. Um, yeah, and then okay, at the start of the talk, how they work token by token. I remember seeing this Google presenting a diffusion-based model. Yeah, so at the moment, diffusion-based language models are still inferior in quality to autoregressive models. What you're talking about, going token by token, what these are but they are extremely promising and they are unifying. So when I talked about how the image generation world has their own notion of sampling, but it involves like differential equations, the diffusion language model world is unifying these two things together. So what I would say is that AI labs are absolutely putting a lot of research effort into that paradigm. But I would say for at least probably 2 to 3 more years that autoregressive methods will be superior. And furthermore, even if they had a diffusion language model that was better, the fact that it's way harder to control them with current sampling techniques means that I think that companies, except Grok, who doesn't care about safety, right? But the other companies will probably be slower to release that just because of fear of control. Um, Yes. Yes, cool. And I'm glad you posted that link. Yeah, this artifact website is for the people that need it, it's very important and gets referred to a lot, but I lose that link a lot. So um I don't think I have anything else. I think we have 5 more minutes if there's any further questions. Otherwise, yep. Okay, then there's this question about how do we stay on top of new samplers and models? And my apologies for the background noise. Samplers has been a world that's been rapidly advancing, and I would say that there wasn't too much academic interest in them Like there was some, right? But it would happen like one or two papers a year. And then our MinP paper came out, and because we got this oral presentation accolade, we're now seeing we've already seen 42 papers cite us, and that's just in a few months. So it's on its way to be a high citation paper. So I guess I could point you to whoever's citing the MinP paper. But I would say I would have told you you could go to the documentation for Hugging Face's model.generate function. But unfortunately, Hugging Face, I'm actually in the middle of a dispute right now with Hugging Face's maintenance staff because Hugging Face is trying to simplify their API, and they've decided to stop merging new samplers to Hugging Face's code. And so from now on, they're expecting people to basically they'll have a function that allows you to pass it's I don't know what it's called, but it's basically like custom sampler equals, and then you'll pass in like a URL to a GitHub somewhere. It'll be like github.com like this, right? And then this will be some code that has custom sampler code in it. And the reason you can do that is because the code for MinP or TopP is ridiculously simple. I'm so blessed to work in LLM sampler space because I don't have to learn like difficult code on getting LLMs to improve themselves. And so what that also means is that it's simple for somebody to write up their own sampler and host it on their own GitHub repo and then anybody to apply it. But I don't like this solution because it's bad for discoverability. So what you're asking about, like, how do you discover new ones? Honestly, go to the conference proceedings of like NeurIPS, ICLR, ICML. These are top AI conferences, and just start searching the keyword sampler, or even on Archive, which is where non-peer-reviewed stuff is posted as well. Um, then I saw, yeah, the other link posted. Um, and has it been evaluated with context plus prompt or only prompt? You can go to the paper for those answers. We have that all in the appendix. We do context plus prompt, specifically a system prompt alongside the user prompt, and we evaluate it on GSM8K, GPQA. So those have differing prompts, but we evaluated on many different data sets with different scenarios. And we also have had independent replication of our technique by several other papers in different contexts. So yes, it is superior to top P in general. And I will point out that min P and top P have equivalency. So top P of zero point 0.9 means the top 90% of the distribution. This is basically equivalent to min P equals 0.1. It has been proven, at least in the case of a uniform distribution, to be exactly equivalent in a follow-up paper. So if you're looking for like a drop-in replacement, you should think of them as inverses. So if you had like a top P of 0.8, you'd want a min P of 0.2 and etc. Right. So and in general, the mathematical understanding of like these P values and how to choose these is it's still emerging. And in fact, the top AI researcher guy who I was calling out in my presentation and who asked the first question, his question to me was that exact same question you asked, Emmett. So you're on the right right kind of thing. So I think we're at the end of time. I could ask one final question if there's anything else, but otherwise, I will adjourn, and I'm more than happy to help with any kind of implementation details or related for your journey of kind of bringing the light of advanced samplers to our customers, at least the customers who are able to use open source or open access models. And as Esteban mentions, we'd really love for you to take a minute to fill out the feedback form about this talk. I realize this was probably much more academic than the rest of the talks here at FSD, but hopefully this really does have value for you. Um, yeah, Emmett, please message me on Google. I can talk with you about how to run, big models on small devices. It's always an emerging, rapidly advancing world. You want to look into Llama CPP for M series MacBooks for running bigger models. But unless there's anything else, I'm going to stop the recording on screen sharing, and we will adjourn.